Hi guys, Quandarius here, and today we are gonna try to solve an easy yet tricky probability question. Suppose that x and y are independent random variables, each standard normally distributed. The question is, what are the variance and the standard deviation of the difference of random variables? In other words, what are the variance of x minus y and the standard deviation of x minus y? The confusion here arises from the fact that we directly do not know the formula for the variance of the difference, but we know the formula for the variance of the summation of two independent random variables. And we know that the variance of the sum of random variables is the same as the sum of the variances of two independent random variables. Okay, but to move forward, we need the second property of the variance. And the second property of the variance tells us that if we multiply a random variable by a constant factor or a constant scalar a, so meaning that we multiply constant a by a random variable y, this is the same as a squared times the variance of y. Okay, we are not gonna prove this property and this one as well. If you don't believe that this is true, you can find several proofs on YouTube. So here you just have to believe that it's indeed true. Okay, and one more step is that, for you too easy to follow, is that if random variable has a normal distribution, it basically has two parameters, mu and sigma squared. So this is just the random variable. And mu here is the mean, and sigma squared here is the variance. And we have two random variables that have the same parameters. They have the same or equal mu equals 0, and they have the same variance. Variance equals 1. And from the variance we know the standard deviation. Standard deviation equals square root of 1 or plus or minus 1, but we don't take negative values because standard deviation can be a negative number. It's strictly 0 or positive, so here we have that the standard deviation equals 1. Okay, with that information in mind, we can try to somehow manipulate the variance of the difference of independent random variables. And the first step is to try to manipulate this part to get the variance of the sum of two random variables. And basically it's an easy step. You just have to rewrite this not as the difference, but as the summation of two independent random variables. And that equals to the variance of x plus, in parentheses, negative y. Okay, now we've rewritten the difference as the summation of two independent random variables. And with that, we can follow and decompose it to two variances, or the sum of two variances, which is exactly equal to the variance of x plus the variance of negative y. Now, we can say that it's the same as variance of x plus, now we can look at the second property. Here we have negative y, but negative y is the same as negative 1 times y. So we can factor out the scalar or the constant like that, negative y times y, negative 1 times y. Okay, now here we have that a equals negative 1. And we can factor this out. Variance of x plus negative 1 squared variance of y. Okay, and all of that equals 2. So this equals 1. And all of that equals to the variance of x plus the variance of y. And here it is. We have the variance of x. The variance of x is 1. And the variance of y is also 1. As we've said, they have the same parameters. So the variance of the difference of two random variables is the same as the variance of the sum of two random variables and equals to 2. And it follows that the standard deviation is the square root of the variance, which is equal to the square root of 2. And now we've found the standard deviation and the variance of the difference of two random variables. And here we also can look at the very interesting result that the variance of the difference of two random variables is the same as the sum of the variances of two independent random variables and the same as the variance of sum of two independent random variables. And this is true for any independent random variables x and y. The key drivers are that when random variables are independent, the variance of the sum is the sum of the variance, and that the variance of negative y is the same as the variance of y. In this particular case of standard normal random variables, another way to think about this is that because y is symmetric about 0, we know that the standard normal random variables or the standard normal distribution is symmetric. The signed random variable or the negative y is from a probabilistic standpoint the same as the random variable y. That is, if we have y that has a normal distribution with the parameters 0 and 1, then negative y also has a normal distribution with parameters 0 and 1. So the sum of the random variables, independent random variables, or the difference of independent random variables and are then probabilistically the same. That is, the random variables x plus y and x minus y have the same mean, the same variance, the same skewness, the same kurtosis. Okay, and let me try to draw you the picture so it's easy for you to understand. One more time, the standard normal distribution is symmetric about the mean, which is 0 in this case. This means that the distribution looks the same on both sides of the mean. Okay, and when you negate a standard normal variable and make negative y from y, you essentially flip the distribution about the vertical y-axis, meaning that if you have a distribution, it's not exactly bell-shaped curve, but anyway, and you have a mean of 0. Here you have 1, here you have 1, here you have 2, here negative 1, and here you have negative 2. Essentially, when you take negative y, you just flip the distribution about the vertical axis, meaning that this negative 2 becomes positive 2, this positive 2 becomes negative 2, this this -1 becomes 1, this 1 becomes -1, 0 stays the same, that's why we have the same mean. And you essentially just flip the distribution and it not goes like that, it essentially goes like this. But it's exactly the same with all the parameters, skewness, kurtosis, etc. So, okay, we solved the question. We get through all the explanations. Thank you for watching. Stay tuned.